So now that we've defined what moments are, let's go ahead and do a few examples of calculating moments. Let's start with this first example up here at the top left, where we have a force equal to 20 pounds, and we have a distance of just 1 foot. And our moment, you may recall, was just equal to our force times our radial distance that we'd create if we turned this wrench. And so our force, just plug in these numbers, our force times our distance, which is 1 foot, okay? And what do we get? We get a moment of, hopefully you don't need a calculator to figure this out. We say 20 times 1 is just 20, and feet times pounds is just foot-pounds. And so we get a total moment of 20 foot-pounds applied to this wrench. And so let's go ahead and give this second one a try. We can say, well, the force is still 20 pounds. And the distance this time is 9 inches. And so let's actually pick a different color this time for our moments to differentiate our examples. We'll say this one is the pink moment, the second example, and that is still just the force times the distance, and the force is still 20 pounds to keep things nice and simple for us. But this time the distance is measured in inches, and you might recall moments and torque in the US system are measured in feet, foot-pounds. And so we actually have to convert this inches into feet. And so how do we do that? Well, we say, well, there's 12 inches in a foot, and this has 9 inches. And so we just say, what is 9 divided by 12 to figure out the percentage, which is 75% of a foot, or 3/4 of a foot, or in this case, 0.75 feet. And so 9 inches is 3/4 of a foot. We plug that in here. We say 0.75 feet. And then we can go ahead and calculate that. We can say, well, what is 0.75 times 20? And we get a total moment of 15. So let's go ahead and write that out. We say our moment is equal to 15, and feet times pounds is still foot-pounds. Let me actually go ahead and box this one in as well. And then let's go ahead and take a look at this third example where our force is still 20 pounds. But if you look at this example, something weird's kind of going on. We got this weird L-shaped wrench. And I want you to ignore the fact that this would clearly just come off this hex nut that it's attached to. If we push on this wrench in this direction, it would slide off. Let's pretend like it's attached in a way that it can't just pull off of the edge there. But let's try to figure out the point of this example, what they're trying to get across here. And that is, we have some parallel distance to the force we're applying. And that would not affect the moment that we are creating. This would hypothetically rotate around our center point. And so we only care about this perpendicular distance, which is 3 inches. But again, we do need to convert that into feet. And so how we do that, just like before, we take 3 inches, go into or divide into 12 inches to make a foot. And what do we get? We get a 1/4 foot, or 0.25 feet. And you might have been able to figure that out by saying, well, 3 is 1/3 of 9, and so 0.25 will be 1/3 of 0.75. You might have been able to do that in your head. And if you could, good for you. But some of us are a little math challenged, and let's choose a different color for our moment this time. We use our third example is a brown moment. We'll say, okay, this is what, 20 pounds still, multiplied by our distance, which is now 0.25 feet. And so we plug that into our calculator. What is 0.25 times 20? And we get 5. So we get a moment of 5 foot-pounds in this L-shaped wrench here. So now let's move on to this example down here with this weird Z-shaped wrench. And this one hopefully makes a little bit more sense than this one did, what's going on. But this force will create some rotation around the center point. And again, the idea is this parallel distance to our force will not affect our torque or our moment in any way. And so, okay, what is our distance? Well, we look at the perpendicular distances from our center point to our force here. And so we got 8 inches and 10 inches. And so we could say our distance is equal to 8 inches plus 10 inches, or just 18 inches. And we go ahead and write down our force while we're at it. Our force is, what, 20 pounds still, keeping things nice and simple. But then we need to convert inches into feet, and so we can go ahead and do the same process we've been doing. We divide 18 inches into 12 inches that make a foot, and we get 1.5 feet. And if you think about it, that does actually make sense. If we separate 18 inches into 12 inches and 6 inches, 12 inches is a foot, 6 inches is half a foot, makes sense that we'd have 1.5 feet. But if that doesn't make sense to you, again, that's what calculators are for. But from there, let's go ahead and solve our moment. And this time, let's make this moment, I don't know, let's make this fourth moment purple. So we'll say our moment is equal to our force, which is 20 pounds still, multiplied by the new distance of 1.5 feet. And so what do we get? Well, if we plug this into our handy-dandy calculator, we take that 1.5 feet and multiply it by 20 pounds, we get a moment of 30 foot-pounds. And for this last example, you'll notice that we're actually using the metric system. Okay, so we have some force applied to the side of some steering wheel. Looks like a old pirate ship boat wheel, but there's 100 newtons going down right here at this point in our wheel. Okay, and it looks like the radius of this wheel is 50 centimeters. So we say our force is 100 newtons, and we'll say our distance is 50 centimeters. But just like in the US system, how a moment was measured in foot-pounds, we couldn't use inches. We can't use centimeters in the metric system. And let's choose a different color for our moments this time. Let's see, we use pink and brown and blue. Let's make this moment orange. Well, moments in the metric system, just like torque, aren't measured in Newton centimeters. They're actually measured in Newton meters. And so we actually have to turn this centimeters into meters. And so the question becomes, well, how many meters is this? And well, if you say there's 100 centimeters in a meter, well, 50 is half of 100. And so we can assume that this is 0.5 meters. But from there, we can go ahead and solve for our moment on this wheel. And we say, okay, it's 100 newtons. So we say 100 newtons multiplied by our distance, which is half a meter, or 0.5 meters, okay? And what is 100 times 1/2? What is half of 100? And hopefully you can do this in your head, but if not, again, that's what calculators are for. We get 50, so our final answer is a moment of 50 Newton meters being applied to this wheel.